Hey everybody, and welcome back to another fun and exciting geometry class. In today's lesson, we'll be in chapter 4, lesson 25 and 26, and that is on page 229 in your books. 229, you can also look down here at the screen. We're going to be talking today about projections. What is a projection? Well, a projection is exactly what you think it is, right? You've heard that word before. So like a projector does what? It puts light onto a wall or onto a screen, and it puts a picture onto the wall. Now, projection in geometry is really the same thing. We're taking one thing and projecting it or putting it onto something else. So the first one that we'll be talking about is when we project a point onto a line. The second one is when we project one line onto another line. All right, so what are we talking about here? Well, here's my point, okay, and then here is my line. So what we're going to do is we're going to take this point right here, and we're going to project it down onto that line. Here's one way to think about it, and again, this probably makes sense because of the whole idea with the projector. Like if we take a light source, like the sun or a light bulb or something, and we put it directly over top of our point, reflecting its rays straight down, what's going to happen to this point? Well, what's going to happen to this point is that there's going to be a shadow, if you will, and that shadow is going to form a straight line. Again, our light source is directly above it, and so it's projecting this line straight down. So when you project a point onto a line, it creates a perpendicular line. Now, if we were to move our light source over here, let's say, yes, I get it, the projection is going to look a little bit different because it's going to be coming at a different angle. But what we're talking about is when the light source is directly above the point. It's going to project it straight down in a perpendicular line. And so what's formed here is we're going to have two right angles, right? So we're going to have a perpendicular line, and then all of the different things that go along with perpendicular lines, all of the rules, definitions, things like that that we've learned would go from that. You know, things like this, we could draw make triangles, and they would all be isosceles, right? We've learned all those different things about perpendicular lines. All right, the next one is when we have a line being projected onto another line. Now, again, our light source, you got to think about the light source, is directly above this line. So what's going to end up happening is this line is going to project straight down to and be on top of that other line, and the whole thing is coming down, right? It's not with a point, it's only one spot that's coming up, but this is like the whole thing is coming down. If we put a light source above that line, that whole line, think of it as a shadow. You know, if we had like a point, I think the book labels these A and B is the line here, and then C and D is this line here. So wherever these projections fall, right, it's going to be, they label it like E at this point, and then this is going to fall straight down, and you're going to get F at this point. So it's going to create a new line on the line, okay? Now, one thing to think about is that line always going to be the same size as the original line? And the answer is no. So in this, you might not be able to see it. You might say that looks like really close to the same size as the original line. So let's make CD with a little bit more of an angle to the original line, okay? So if we take CD and we make it, let's say we make it the same length that it used to be, right? So the same length that it used to be gave us this E and F projection, okay? So we have E down here, and that's when it was projecting up here, and we had F here when it was projecting here. But look, as we tilt that angle, you'll see that E and F are actually moving in. The projection ends up coming and gets smaller. So the more of the angle, and as we stand that up straight, like if it's a straight line, then it would be a perpendicular line with our original. So it wouldn't really have any length at all. It'd just have a very short length based on how you tilt that line. So the more horizontal that line or the more parallel, if you will, that it gets with AB, it's going to be the same size. But the more vertical that it gets with AB, the smaller that it's going to be, and it's going to be so it can change based on the angle. That's important as we go on to some of these next questions. So what I want to do now is I want to look down at exercise 4.26 in lesson 426. There's not really any teaching that goes along there, but if you look down there, it does have several problems with the little asterisk next to them. What does that asterisk mean? It means that those are important. In fact, there's new material being taught in those lessons. So let's talk about triangle projections. So what it says there in question number 1 is it says, in any triangle, the square of the sides. Basically, this is almost like a corollary to this. And I kind of wish that they would have made this. I'm going to have an argument with Euclid here. Yes, I know. But I kind of wish that Euclid would have made this a theorem, right? Because then it would have a corollary. But this is just kind of something that's like a side note that's being taught. So it doesn't have a theorem, doesn't have a corollary, but it does have important information that you need to know. All right, so acute angle, the square of the side opposite the acute angle is always equal to. So what are we doing here? We're doing this formula right here. All right, so the square of the opposite side. So the square of our opposite side, a squared, is always equal to, there's an equal sign, the sum of the squares, there's the sum of the squares of the other two sides, minus twice, there's the 2, the product of one of those sides, there's the C side, and the projection of the other side. That's what that P stands for, is the projection of the other side. Now, let's hash this out just a little bit, because that, yes, this is, again, given to you, but it's not given to you in a theorem. So let's talk about why this is true, and let's kind of work through that number 1, if you will, on page number 229. I'm not going to do it in like an actual proof form. That's what they're asking you to do, but I'm going to walk you through what this kind of looks like. All right. So again, what we're looking for, I guess the missing piece is this right here. A equals what? This is what we're looking for. We want the side opposite of our acute angle. So this is the acute angle we're dealing with. And so we're looking for what is the A. A equals what? Okay. Now, let's think about this. Let's think about projections. So now if we take this, this line up here, so if we take this line, this B line, and we project it down, what's going to happen? What's going to end up happening is we're going to get a perpendicular line that is perpendicular to the C, okay, our C line down here. Now remember, this is the one we're dealing with down here, right? So don't get focused on the right angle that we just created, although we will come back to that in just a second. What we want to say is, what the book is saying is that A squared, this side opposite our acute angle right here, is equal to B squared, this side right here, plus C squared, this whole side down here, minus 2PC. What does B equal? What does C equal? What does P equal? We don't know any of that. So what we're doing here is we're not using real numbers. We're just going to use the letters. We're just going to kind of manipulate this using some different theorems from the past that we know, different things about Pythagorean's rule, things like that. Okay, so the first thing that we want to do is we want to think about this triangle that we just created right here. We created a right triangle, okay? The other thing that we could do is we could call this side right here, we could call this side H for height, because what we've done is that projection has created a height. Now, earlier when I showed you this line coming down, remember how I told you that that angle changes the length of this? So we don't know how long this is going to be when it kind of rotates down there, when the projection comes down. Because this starts at the line, and this whole projection is coming down to that other line, right? Well, we don't know what that's going to look like. We don't know the length of that. We can't say that this line right here is going to be b inches long. We don't know that it's the size of b, okay? Let's call this one d, actually, for now, this point that we've created right here. So what we do know is this is called, I'll use green for this new stuff that I'm putting on here. This is the projection. This piece right here is the projection of this coming down, this B side coming down. What this is over here, what BD is it's this whole side C, right? Minus the projection. Why? Because the projection is from here to here. And so this is the remaining part once we subtract out our projection. So this is going to be C minus P right here. This little piece, dB, is going to equal C minus P. All right? So now we really have everything labeled up. We've got everything now that we need. So if we kind of look around this, this is B, right? This is P. This is H. This is CP, C minus P. All right, this is A, so we know what all of our pieces are, so that's good. So now what we can do is start plugging into the Pythagorean theorem. Why? Because we know that this piece right here, okay, this triangle over here is going to give us a squared plus b squared equals c squared. Also, this triangle over here is going to give us that same thing. So what we want to do is just kind of start over here, and we're going to work our way over to this missing piece. So let's kind of write this one out. Let's write this first one out right here in Pythagorean theorem. So in a squared plus b squared equals c squared. So here's our right angle. So this is going to be our hypotenuse. So let's write it out the Pythagorean theorem way first, like c squared equals a squared plus b squared. Okay, now let's translate what we're given in this triangle into this formula. What do I mean by that? Well, our hypotenuse is not c. In fact, it's c is down here with the right angle, and we're not even using c because c is the whole thing. So C is not even part of this little triangle over here. So you see what I mean? We're going to put our pieces into the Pythagorean theorem. So across from that is going to be B. So that's going to be our hypotenuse. B squared equals, one of our sides is going to be P, so we'll call that P squared. And then our other side is going to be H, so we'll call that H squared. Again, we're not using numbers, we're using letters to kind of see the progression of this. Now, let's do the same thing with this triangle over here, and let's take a look at this. So we'll call this, I'll call this triangle 1, and we'll call this one triangle 2. All right, so what's triangle 2 look like? Well, what's our hypotenuse? Our A side is our hypotenuse. Ooh, that's what we're looking for. That could actually come in handy. So A squared equals, we'll just pick one of the sides, so we could pick this one right here. What's that one? C minus P. C minus P, and we would need to put that in parentheses because it's the whole thing is what this side equals. And we've got to square that, and then we got to add the other side, which is our H side. All right. Now, let's kind of like look at what we have here, and let's see if we can kind of plug some different things in. Now, watch what happens if we get H by itself. Now, the reason we would get H by itself is so that we can plug it back into this instead of having H. We want to eliminate variables is what we're trying to do. So if we kind of plug that back in there, we could get H by itself by subtracting C minus P squared from both sides. So A squared minus C minus P squared equals H squared. Okay, I just moved the Pythagorean theorem around in this one. So now what we can do is take this and plug it in for that. All right, so now we're going to end up with B squared equals P squared plus this right here. Okay, A squared minus C minus P squared. Now this is probably the trickiest part of the whole thing. Not really, but we need to expand this. Okay, what does that mean? this right here, we can actually square this. This is a binomial, so we can square this. We're going to get b squared equals c squared plus a squared, and then we're going to get minus, and we're going to actually square this. How do we square that? C minus p, we're just going to actually do it, right? C minus p times c minus p, and we're going to FOIL it. So first gives us c squared. Outers gives us minus CP. Inners also gives us minus CP. And then last gives us minus, that's going to give us plus P squared. All right, don't forget that all of that we just did is still inside of parentheses. We need to distribute this negative sign to everything. So what we're going to get here is we're going to get b squared equals p squared plus a squared minus c squared. So this is going to be a plus and a plus, so we're going to get plus 2cp, and then that minus is going to go to that, so it's going to get a minus p squared. Now we can keep simplifying. So look, we have p squareds. One's positive, one's negative. That's going to cancel out. So we end up with b squared equals a squared minus c squared plus 2cp, and that's it. But we want to solve for a squared, so we have to subtract b squared from both sides, and we have to subtract an a squared from both sides. So that's basically going to switch those two things. So we're going to get negative a squared equals negative b squared minus c squared plus 2cp. Now, we don't like this negative out front, so we need to multiply everything by a negative all the way through. We're going to distribute it all the way through to get rid of that negative sign. So there's our positive a squared equals positive b squared positive c squared negative 2cp. All right, that's a ton of work, but that got us back to where we started from. Where did we start? This is our formula right here. There's our a squared equals b squared plus c squared minus 2pc or cp. It doesn't matter which order you put those in. We can switch those and it doesn't matter. So that is how you kind of delineate that formula. Sometimes it's good to just review that, right? Because that was algebra, and it's been a while since you've been in algebra class. So hopefully you were able to follow that. And that's what they're asking you to do in these next few problems, is to take those projections and kind of like figure out how would I solve these different types of triangles. Look through the next one. The next one talks about obtuse triangles instead of acute triangles. So that's all I've got for you. Hopefully you learned something there. Hopefully you were able to follow that. If you missed anything, if you need some practice on that algebra, slide it back, watch it again. Make sure that you're kind of following those steps there on how to delineate that formula out. So, all right, we'll see you later. Have a good one. That's all I got for you. Bye-bye.